Welcome to Maths and Science by IITian channel. We will be continuing our lectures on linear algebra and matrices properties, useful for JEE and Maths Olympiad and JEE Advanced also. In this, we will analyze the idempotent matrix, very important matrix in matrix algebra. A square is equal to A, its property, but as everybody thinks A square is equal to A means A is equal to I, but the condition is A is not equal to I. Then what is the value of A and what are its properties? This type of matrix is called as idempotent matrix, very important matrix in data sciences and also in engineering applications and in computer science. A square is equal to A, provided A is not a identity matrix, A is not a unit matrix. Then how A square is equal to A will be defined, and what is the value of A square is equal to A and what will be its properties, how they will be unique, so that you will get trace of the matrix, rank of the matrix and also determinant of the matrix. Everything you will get, and you will get in this matrix, and you get the understanding and definitions of all these properties. It's a very good lecture. Please listen to it carefully, and if possible repeat the video and see it again and again, and also make a note of it. It's a very important matrix. What is given? Condition is A square is equal to A, but A is not equal to identity matrix. Then we have to analyze what it is. Let us take one 2 by 2 matrix as an example and let us try to do. Solution. Let A is equal to 1 0 0 0. Then what is A square? A square is equal to 1 0 0 0 1 into 1 0 0 0. That is equal to 1 0 0 0, that is equal to A. That means, therefore, A square is equal to A, satisfied for the above matrix. Now, we will go one by one the properties of it. What is the trace of it? For a diagonal matrix, it's a diagonal matrix. One, it is a diagonal matrix. For a diagonal matrix, trace is equal to, or for any matrix for that matter, trace of A is equal to sum of the elements in diagonal, principal diagonal. Is it correct or not from the definitions? We are defining these properties, we are recollecting what we have learnt. It's a very good matrix. Please try to understand. What is trace of A here? Sum is 1 plus 0, that is equal to 1. Trace is unity, that is trace is 1. Now, can you find out the eigenvalues? What is the eigenvalue? A is equal to 1 0 0 0. A minus I lambda is equal to matrix 1 minus lambda 0 0 minus lambda. Do you agree? That implies determinant of 1 minus lambda 0 0 minus lambda is equal to 0 for finding eigenvalues. Which implies 1 minus lambda into minus lambda is equal to 0. That implies lambda is equal to 0 or 1. That means eigenvalues are 0 and 1 because two eigenvalues. It is a quadratic equation. 1 minus lambda into minus lambda is equal to 0 is a quadratic equation, and lambda value is either 0 or 1. Next, the determinant of the matrix is the product of the eigenvalues. You see how we are getting all the properties. In this only you will learn everything. Determinant of a matrix is equal to product of eigenvalues. That is equal to 1 into 0 is equal to 0. You just say, now you find out, you prove it. What is the determinant of 1 0 0 0? That is equal to 1 into 0 cross multiplication, which I have explained in the previous classes. Please see those lectures. That is equal to 0. That means determinant of a matrix is equal to product of eigenvalues is also proved in this matrix. Idempotent matrix. These are the properties of idempotent matrix. Number 4. Sum of the eigenvalues is equal to trace sum of the eigenvalues is equal to trace of A. Sum of the eigenvalues is 0 plus 1 is equal to 1, that is equal to trace of A, that is equal to sum of the diagonal elements. 1 plus 0, that is equal to 1. This is also a property which we have recollected. Now, next, is it a symmetric matrix? Yes, the elements below the principal diagonal and above the principal diagonal are same. What is the matrix here? Matrix is 1 0 0 1 0 0. Now this is the principal diagonal. Above the principal diagonal 0, below the principal diagonal is 0. That implies it is symmetric. What is the property of this matrix? A square is equal to A. It is symmetric. Now, invertibility. Here the condition is A is not equal to I. When A is not equal to I, the determinant is equal to 0. If A is not equal to I, determinant is equal to 0. That implies it is invertible. It is not invertible, or it is singular. Singular means non-invertible. We cannot invert it because determinant is equal to 0. Not invertible. Non-invertible. Non-invertible means singular. Provided A is not equal to I, because that's what is asked for us. Now, I will give some more properties which you kindly take them as homework and prove. 1. Prove that given matrix is nilpotent. Or not nilpotent. You find out whether it is nilpotent or not nilpotent and prove that. It's not that just make a statement, prove it. Second, find whether trace of A is equal to rank of A. Rank of means, I have already explained you rows and column operations. When you do the elementary rows and column operations, if any column or row has become total 0 elements, that row and column is to be left over, and the remaining column which has non-zero elements or row, that can only be counted. And here in this case, I will solve this. Here in this case 1 0 0 0, because only one row is having non-zero element, that is 1. Hence, rank is equal to 1. Only one non-zero element, only one row. Second row is full of zeros, we have to eliminate that. When you eliminate this, only one is there, non-zero element, only one row, hence rank is 1. And trace of a matrix is equal to idempotent matrix trace is equal to rank of the matrix. It is also very important derivation. Please remember all these properties, important properties. This I have already proved. Next, is a to the power of k is equal to a or not? Try to prove this. Third, find if a to the power of k is equal to a for all k is greater than 1. If so, prove it. This is called as power property. And you can have some more proofs also. Some more things I will give you on the basis of this. These are the properties which you can do. You please try to understand these properties. If IN is equal to identity matrix, then IN minus A, this given idempotent matrix whole square is equal to IN minus A. Prove this. Is it correct? Prove this. Then another thing, rank of A plus rank of IN minus A is equal to N corresponding to IN. Prove this also. If you have any difficulty in proving these theorems, please put it in the comment section. I will give the solution to you. That means almost 10 properties of matrices, 10 properties of matrices A square is equal to A matrix where A is not equal to IN are discussed and proved. Some 2 or 3 are left for you. You please do it on your own. If you have any problem, please comment in the description and please comment on the handle. I will reply. Thank you for listening to me. Thank you for viewing this lecture. It's a very important lecture as far as matrices is concerned. With this, the properties of matrices are completed. And also, the matrices operations are also to maximum extent we have completed, including the elementary operations. Matrices, properties, elementary operations, row column operations, and the definitions, operations are completed. Now, next is to go to determinant, even inverse in Gauss-Jordan method also we have completed. Now, next class we will be talking about the determinants, and with determinants we will be talking about the inverse and other operations and characteristic equation and Cayley-Hamilton theorem. With this we will be completing the matrix. This is due. This will be taking up next class onwards. And whatever, if you have any doubts in this, you please put a comment. I will reply to the comment definitely. Best of luck to everybody. Thank you for listening to me. If value addition took place because of this video to you, please share this video to all concerned and subscribe to my channel Maths and Science by IITian. Thank you.